Introduction to X-ray imaging. X-ray imaging is a medical technique that uses electromagnetic radiation to produce pictures inside of the body. It was discovered by Wilhelm Conrad Röntgen in 1895 and became one of the first major tools in medical imaging. X-rays can pass through the body and different tissues absorb them at different levels. Dense structures such as bones absorb more X-ray and appear white on the image, while softer tissues appear in shades of grey or black. This makes X-ray imaging a useful and non-invasive way for doctors to see internal structures without the significance of X-ray imaging. X-ray imaging is significant because it helps doctors diagnose many conditions including bone fractures, infections, lung diseases, dental issues, and certain types of cancer. It provides fast and accurate results, which is especially important in emergency situations. X-ray also guide various medical procedures, such as surgeries and orthopedic treatments. They are commonly used in routine screenings like chest X-rays and mammograms to detect problems early. Beyond healthcare, X-rays are used in airport security, industrial inspections, and scientific research. Overall, X-ray imaging plays an essential role in identifying hidden structures safely and efficiently.
Now I will explain to you about the relevant electricity and the magnetism concept of an X-ray. So it's basically, I will explain about the concept behind X-ray. So X-ray is a form of electromagnetic radiation. So the origin and behavior are rooted in core of ENM principle. So the first concept that I will explain to you is about the accelerating charge emit electromagnetic radiations. So it basically based on a fundamental result from a classical electrodynamics. So any accelerating electric charge emits electromagnetic wave. Okay, so in an X-ray tube, the electrons are accelerated through a very high voltage. It is about a tenth of kilovolts. So when the high speeds electron suddenly decelerate upon hitting a metal target, so they will emit the Bremsstrahlung radiation, which includes the X-ray. So for the next point is about the high voltage of the electron acceleration. It is basically based on the electric field concepts. So inside the X-ray tube, a large potential difference, which is E equal to V over D, create a strong electric field. So the strong electric field will pull the electrons of the heated cathode and accelerate them to the high kinetic energy, which will direct them towards the anode target. Okay, move on to the third concept, which is the X-rays are electromagnetic wave. X-rays follow all the EM wave principles such as transverse, oscillating electric and magnetic fields, speed of light in vacuums, and wave particle duality, which is basically a photons. So Maxwell equations predict their existence because accelerating charges generates EM wave of all frequencies, including X-ray. And moving on for the last concept of relevant electricity and magnetism concept of an X-ray. So the last concept is about magnetic field are less central, but magnetic acceleration is possible. So what is the meaning by the magnetic field are less central, but magnetic acceleration is possible? So in a typical X-ray tube, electric field is dominant, but in some systems such as synchrotron radiation, charged particles are forced into circular path using the magnetic field. The accelerated electron emit very intense X-ray. So these concepts connect magnetism to X-ray productions.
One of the most common real-world applications of X-ray imaging is in the medical field. In hospitals and clinics, X-rays are used to detect bone fractures, maybe examine the lungs, and identify dental problems. X-rays can pass through soft tissues but are absorbed by denser materials like bones, allowing doctors to see internal structures. And very clearly, X-ray imaging is also widely used in airport security systems. Luggage is scanned using X-rays to detect dangerous or prohibited items such as weapons and explosives. Different materials absorb X-rays differently, allowing security officers to distinguish between metals, plastics, and organic items. In the industrial sector, X-ray imaging is used for non-destructive testing. It helps detect internal cracks, defects, or weakness in metal structures, pipelines, and welds without damaging the object. This is important for ensuring safety and quality in industries such as construction and aerospace. X-ray imaging is closely related to electricity and magnetism. Inside an X-ray tube, a high voltage is used to accelerate electrons. Magnetic fields help control and focus the electron beam. When the electrons strike a metal target, X-rays are produced. One of the main benefits of X-ray imaging is that it allows fast and accurate diagnosis without surgery. It is a non-invasive technique that helps doctors detect problems early. X-ray imaging also improves safety and efficiency in areas such as airport, security, and industrial inspection. Despite its benefits, X-ray imaging also has several challenges. X-rays involve exposure to ionizing radiation, which can be harmful if used excessively. The equipment is expensive and requires trained professionals to operate it safely. Therefore, strict safety guidelines must be followed.
Today, I'm going to show you 3 futuristic X-ray innovations that will transform medical imaging. These ideas aren't just science fiction, they are based on real physics and real technology that scientists are developing right now. First, we have ultra-low dose X-ray, safer than ever. Imagine getting an X-ray with almost 90% less radiation. Future machines will use photon counting detectors, sensors that can detect each individual photon of X-ray energy. Because of the detector is more sensitive, we don't need a high dose to get a clear picture, which means safer scan for children, pregnant patients, and anyone needing frequent imaging. Next, we have AI-powered X-ray. Instead of waiting minutes for result, AI clean up the image almost instantly and even highlight fractures or tumor automatically. But the coolest part, AI can reconstruct 3D image from just a few 2D X-ray angles, almost like building a 3D model from shadows. This means doctor can get clearer, faster, and more intelligent imaging. And finally, X-ray device may also soon become light, portable, or even affordable. Using carbon nanotube (CNT) emitters, we can generate X-ray using much lower voltage, allowing the machine to be smaller, maybe even as compact as laptop. That means ambulance, disaster sites, or home care could one day have instant bedside imaging.
So, in conclusion, X-ray imaging is a vital technology that uses principles of electricity and magnetisms, specifically the acceleration of electrons and the production of high-energy electromagnetic waves to create image of internal structures. Its significance can be seen in real-world applications such as medical diagnostics, dental imaging, airport security, and industrial inspection. While X-rays provide major benefits like fast, accurate, and non-invasive visualization, challenges such as radiation exposure and high equipment costs still need careful management. Looking ahead, advancements like lower dose systems, improved digital detectors, AI-assisted analysis, and 3D imaging promise to make X-ray technology even safer, clearer, and more effective in the future.